Hello students, good morning. This class is for the students of Inter Math. The medium is English. This class is for the board exam, and after competition, after board exam, we will discuss critical problems will be discussed, in which we will discuss in critical problems for competitive exam. In this class, we will discuss important problems of the chapter Rules of Differentiation. In this class, I will discuss short answer question. In this class, I will discuss short answer question of 2 marks. Let us see question number 1. Y is equal to x cube minus a cube by x minus a. This function is of the form u by v. So we will use the formula here for obtaining the DC of the quotient of two functions. Let us see. Here the function is of the form u by v. So we use the formula for the DC of quotient of two functions. Let us see. dy by dx, this is equal to DC of numerator dx cube minus a cube by dx into denominator x minus a minus numerator x cube minus a cube into DC of denominator, that is d by dx x minus a by square of denominator. This is equal to, we know that DC of the constant term is 0. So we write here 3 minus 1 into x minus a minus x cube minus a cube dx by dx minus dA by dx by x minus a whole square. Here I have write in expanded form so that you follow it easily, but in solving the problem you need not write this step. You will directly write as this is equal to 3x square x minus a minus x cube minus a cube into 1 by x minus a whole square. You directly read this step. This has written only to write in expanded form so that you follow it easily. I write next term here. As we know from the algebra, x cube minus a cube equal to x minus a, x square plus ax plus a square, and we take common this x minus a. Here, right, 3x square x minus a minus minus a into x square plus ax plus a square by x minus a whole square. We write it here. This is equal to, we take common x minus a minus x square plus ax plus a square by, sorry, x minus a 3x square minus x square plus ax plus a square by x minus a whole square. 1 x minus a is common, it will cancel x minus a, and 1 of x minus a here in the denominator cancel, and when we have the result as 3x square minus x square minus ax minus a square by x minus a. You write it in your notebook. After that, I write next step. This is equal to, I write next step here. I write next step here. 2x square minus ax minus a square by x minus a. Now factorize it by splitting middle term. This is equal to 2x square minus 2ax plus ax minus a square by x minus a. This is equal to, here take common 2x, here we take common 2x, then x minus a plus 1 plus, here take common a x minus a by x minus a. Now we take common x minus a 2x plus a by x minus a, x minus cancel. This is equal to 2x plus a. This is the required DC of the function. This is the required DC of the function. This is the required DC of the function. We also write it some in next form. And first we simplify the denominator, the function. First we simplify the function and see y is equal to x minus a x square plus ax plus a by x minus a. X minus cancel is equal to x square plus ax plus a. Now we obtain the DC of the function. We obtain the DC of the combination of the functions. Combination of the functions, and dy by dx, this is equal to d x square by dx plus d ax by dx plus d a by square here by dx, and this is equal to 2x plus a plus 0, that is 2x plus a. We also obtain DC of the function by first simplifying the function. Let us see. Then function becomes L, and we will obtain the DC of the function by obtaining the DC of the combination of the functions x square plus ax plus a square. As we know, DC of constant term is 0, and also DC of constant term and the function is equal to the constant term and the function of the and DC of the function, this is 1. So this is 2x plus a plus 0, that is 2x plus a, and this is the required function of the DC. This is the required DC of the function. We obtain the DC of the function in this way, or in this way also. You write it in your notebook. You write it in your notebook. Question number 2. If y equal to tan inverse x, then find dy by dx by first principle or by definition or by ab initio. If y equal to tan inverse x, then find dy by dx by first principle or by definition or by ab initio. Let us see. Let y is equal to fx equal to tan inverse x. Here y equal to tan inverse x and y plus delta y equal to tan inverse x plus delta x. For change in variable, for change delta x in variable x, corresponding change delta y takes place in the value of y. That is here, or x is equal to tan y and x plus delta x is equal to tan y plus delta y. Also, fx is equal to, as we know, tan inverse x. Then f x plus delta x is equal to tan inverse x plus delta x. So here delta y tends to 0 when delta x tends to 0. Here obviously delta y tends to 0 as delta x tends to 0. When delta y tends to 0 and delta x tends to 0. Now from definition we know that definition dy by dx equal to limit delta x tends to 0 f x plus delta x minus fx by delta x dy by dx. From definition dy by dx equal to limit delta x tends to 0. Limit delta x tends to 0. This is equal to limit delta x tends to 0 f x plus delta x minus fx by delta x. Now write in your notebook, then I will write next step. So dy by dx is equal to tan inverse x plus delta x minus tan inverse x by x plus by delta x, limit delta x tends to 0. This is equal to limit delta x tends to 0 y plus delta y minus y, as I have written above, by x plus delta x minus x. You can write delta x as x plus delta x minus x, so that we use the functions. We use the functions. This is equal to limit delta x. This is equal to delta y by tan y plus delta y minus tan y, and we have known that when delta x tends to 0, delta y tends to 0. Here all the terms are in delta y, so we write limit delta y tends to 0. Now I write next step as limit delta y tends to 0, delta y by sin y plus delta y by cos y plus delta y minus sin y by cos y. I write above. I write next step here. I write next step here. This is equal to limit delta y tends to 0, delta y by sin y plus delta y into cos y minus sin y into cos y plus delta y. Now we use the formula of trigonometry: sin a plus b, sin a into sin b minus cos a into cos b. Sorry, sin a plus b, sin a into cos b minus cos a into sin b. Sorry. Sin a plus b is equal to sin a into cos b minus cos a into sin b. See here. We will use that formula. We are going to use that formula here. This is equal to limit delta y tends to 0, delta y is equal to here this will be add by cos y plus delta y into cos y. Now we use the formula. This is equal to limit delta y tends to 0, delta y into, this will come above in numerator, cos y plus delta y into cos y by sin y plus delta y minus y. This is equal to limit delta y tends to 0, delta y sin delta y into cos y plus delta y into cos y. See this. You write it in your notebook, then I will write next step. Now we use the formula of limit to obtain the limiting value of the trigonometric functions. Here we use that formula, and the next step will be, I write it here. This is equal to 1 into cos y into cos y. This is equal to cos square y. This is equal to 1 by sec square y. This is equal to 1 by 1 plus tan square x. Tan square x. And as you know, y equal to tan x. Sorry, tan square y. Tan square y. And as we know, x equal to tan y. As we know, x equal to tan y. So we write it is equal to 1 by 1 plus x square. Thus, dy by dx is equal to 1 by 1 plus x square. This is the required DC of the function y equal to tan inverse x by first principle or by definition or by any issue. This is also the limited differential DC of the standard function y equal to tan inverse x. This is a standard function, and this is the DC of the standard functions y equal to tan inverse x. Dy by dx is equal to 1 by 1 plus x square. This also we remember it as a formula. You note it in your notebook. Okay. Question number 3. Y equal to x to the power a by x to the power b whole to the power a plus b, x to the power b by x to the power c whole to the power b plus c into x to the power c by x to the power a whole to the power c plus a. Here we first simplify the function and then obtain the DC of the function. What we say here? This is equal to x a minus b by a plus b into x b minus c by whole to the power b plus c into x c minus a whole to the power c plus a. Here this comes in the form of numerator, then sign changes and becomes this becomes this becomes this. Now this is equal to, we multiply it, x a square minus b square, a minus b into a plus b, whole a square minus b square into x b square minus c square into x c square minus a square. This is equal to x to the power a square minus b square plus b square minus c square plus c square minus a square. This is equal to x to the power 0. This is equal to 1. As we know, dc of constant term is 0. So dy by dx is equal to d1 by dx. This is equal to 0. So the dc of the function is 0. dc of the function is 0. You write it in your notebook. Question number 4. Y is equal to cos x into log x. Here the function is in the form of the product of two functions, and we use the formula for finding the dc of the product of two functions. dc of first function into second plus dc first function into dc of second function. Let us see. Here the function is in the form u into v. Thus dy by dx is equal to d cos x by dx into log x plus cos x into d log x by dx. This is equal to, here we use the dc of standard functions. I have given the dc of standard functions, list of dc of some standard functions. We use here dc of some standard functions which I have remember as formula. So this is 1 by 1 minus x square minus into log x plus cos x into 1 by x. So divide x equal to d cos x by dx into log x plus cos x into d log x by dx. Now we use the dc of standard functions. D cos x by dx equal to minus sin x into log x plus cos x into 1 by x, and this is equal to cos x by x minus sin x log x. This is the required dc of the function. You write it in your notebook.
3.
Question number 5. Y equal to ex by 1 plus x square. Here the function is in the form of the product, the quotient of two functions. So we use the formula for obtaining the dc of the quotient of two functions. dy, here the function is in the form u by v, and so we use the formula for this. Let us see. dy by dx is equal to dc of numerator d ex by dx into denominator 1 plus x square minus numerator into dc of denominator d by dx 1 plus x square by 1 plus x square whole square, that is square of denominator. This is equal to ex into 1 plus x square minus ex into 2x. As we know, dc of constant term is 0 and dc of x square equal to will be 2x. 2 into x to the power 2 minus 1, that is x, by 1 plus x square whole square. Now we write next step here. See here. We take common ex. We take common ex. This is equal to ex 1 plus x square minus 2x by 1 plus x square. This is equal to ex into 1 minus x whole square by 1 plus x square. This is the required dc of the function. This is the required dc of the function. You note it in your notebook. In next video, next class, I will discuss more problems. In next class, I will discuss more problems, other problems, more problems. Please like, share and subscribe my YouTube channel, Mathematics Vibes. I Satish Kumar Thakur, lecturer in math, Rajaram Shah College, Raxaul, Bihar, India. Have a nice day. Thank you.